Right, so we have the components, which is the breadboard. Is it showing here or is it outside the?
I'm showing.
Okay, so we have the breadboard, we have the Arduino board, we have the ultrasound sensor, we have the resistor, we have the LED, and we have wires and we have USB. Perfect, you can do it. So first thing, we copy the code. Oh, you can do it. You missed something, but it's all right. It's okay. Cool. New. Just go to find new. No, everywhere. Just remove everything. Okay. And put it in. You can close this. Maybe you guys should come around so you can see the code. So we have this. Right, so we copied the code. We're going to check that it's valid. We need to save it. So what we're going to call it? Ultrasound. Exercise. Okay? So we're going to check that it's valid. Yeah, it looks it's valid. Okay, that's good. What we're going to do is we're going to check what we've changed. What did we change?
The LED pin to 9.
So instead of 13, we have 9. Go ahead. And did we change anything else?
No.
All right, so we keep everything else as it is. And then we can change things later if you want. So now we need to build the circuit. So we know that this, we can put it like this. And then this wire is VCC, so we need a red wire. And takes it from the VCC pin to 5 volts. Then the trigger is going to pin number 8, so we take green or yellow or orange, anything but red or black. So that will go to pin number 8. Then we have something else, another color. Not something long, something long. No, it's not long anymore. You messed up. Takes another yellow. The yellow is long. Okay. That goes from echo to pin number 7. And then we have the ground, which is from ground to ground. Okay. Next circuit, we have the from ground to the LED, the short leg of the LED. Like this, because by convention we put the sensors and actuator across the groove. Then after the LED, we have the resistor. And then what do we have next?
From that to pin 10. Oh, 9, sorry.
9. Yellow, orange, blue is okay. All right, so we've got the circuit, we've got the, because it's a sensor, we have to make sure it doesn't get. So we've got the circuit, we've got the sensor, we've got the program, let's connect and check. As I said, connecting the USB port is always the biggest challenge. Let's try now. And what you do? Right. First thing, you have here a little, like a loop. That's the serial monitor. And that tells us the value that is being read. And as you can see, that value is going to change and getting closer and closer when I get down. And there is a point where it's very close and the LED is going to turn flash, yeah? But welcome to the reality of the real world, if you excuse the double wording. Sensors never work perfectly. They always mess up a little bit because they pick up noise. And your hand is shaky and blah, 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 and blah, blah, blah. Which means when you're working with a sensor, it's always an excellent idea to have the serial monitor, which is this window, where you display the values of the sensor. What values is the sensor reading? So that you can check, is it happening or not? Because it's working, but yet when I do that, it's not flashing all the time. That's unfortunately because the way the sensor works. So we can change the value at which it's going to flash to make it easy. So for example, and that when we change the value at which it's going to flash, or when we change the value at which something is going to happen, it's called calibrating. So you do your program, you use the standard values, and then you realize it doesn't work very well, so you're going to calibrate, you're going to change the values. And we're going to look now at the program and see where is the threshold for the LED to blink. And we know what we need to look at for the LED to blink is this thing here. So if it's more than maximum range, or it's less than minimum range, the LED is pinning. But the maximum and the minimum range are 200 and 0. Or at the moment, we're going between 170 and 5. So we're going to change that to something that is more meaningful. So for example, 160 and less than 5. And that should be better for us. Because now, when it's giving, so now it's blinking when I'm in the right place, and then when it becomes, why is it going to minus? There's something on the way. No, it should work. So why is that minus? So now, you see now the, So it should be when it's less, that's one, okay? And that shouldn't. Okay, so we need to change some of the values. What, okay, it's a -1. We just put the distance as it's read. So we know exactly what it's reading. Okay. Now it's and as soon as it's less than 170, and it's still above 5, the LED is off. And then we reach 5. When it's below 5, the LED is on. So that means that's the range where it's going to work. You see? So it's a bit more stable. It's not working. It's not detecting anything. It's detecting, and now it's too close. So it's going complete. So what I've done here is calibration. And that is one of the challenges of using sensors, is that you write the code, it all works perfectly, and then you test it, and it doesn't do what it's meant to be doing. Because you need to calibrate your sensors. All right? Thank you. Could you stop the video?